because this is kind of important. Gusto ko na this will be more of a parang face-to-face para real-time na pagka-solve ng mga problems, especially Newton's laws of motion because this topic will go or will you will be discussing or you will go through with this one over and over again as you go along with your engineering professional subjects. So, kaya ni-request ko na sana, hopefully, tayong lahat is nandito. I understand din naman that there are people na hirap sa connection and hirap pa mag ano to, real-time na discussion so far. I have, sorry, medyo na ano ito siya last, kahapon, kagabi lang din napansin, is that this was available already, the materials for this one is already available last Monday. And then, hindi lang pala naka-show sa inyo. And then, kahapon lang ako sinabihan ng students ko na naka-hide pala or walang content or walang laman ang tile. So, kagabi ko lang din na unhide. I thought na diretso siya ma-open kasi ginamit ko lang is i-restrict lang siya. And sad to say, hidden from students pala talaga nakalagay. So, I have to manually open it one by one. So, kahapon lang din na open lahat. So, if you could go to Daigler now, you can download the questions of the examples para mas maklaro niyo siya or mas mabasa niyo siya better. Okay? Kasi I will just stick with this setup as you can see with the presentation. I will stick with that one na medyo maliit lang si problem and then malaki si blackboard. Itong blackboard na tinatawag ko. Okay, and then for today, I will be discussing Newton's first law of motion lang, first law lang. So that's the first 5 problems. And then for the second law of motion, I will go with that one on Saturday, this coming Saturday. And then on Saturday also, I will not open muna si bagong lab. Kaya hindi ko muna ibigay si lab. I will not discuss muna the new lab. Siguro next week na or next week na. Kasi ang balak ko for Newton's laws of motion is that this will be worth 2 weeks. Okay, so worth 2 weeks time ito siya na discussion. So first law muna and then second law. And then 1 week na gawin nyo lahat ng mga backlogs and 1 week na gawin nyo up to kay Newton's laws of motion na discussion. Para pagdating natin sa another week or another lesson, sabay-sabay na naman tayong lahat. Because I understood that people are still having their backlogs pa and then some of you are still doing or clearing things up with backlogs pa. Okay, so that's basically the the cycle or the ano to, not outcome, the target na gagawin natin or target activities natin for Newton's laws of motion or lesson number 3. Kaya sinadya ko siya na medyo dinalian ko si lesson 1 at saka si lesson 2 kasi yan siya ang parang na-discuss na especially for those STEM students na-discuss na during the senior high school. And I understand also that there are people here na hindi enrolled sa STEM, ngayon lang nag-engineering or ngayon lang na-encounter ito sila. So, this is the time na para maka-cope up tayo. And so far, kasi yung first 2 lessons natin is, yun siya ang parang medyo may recall tayo since junior high, grade school, or senior high school. Ito siya, si Newton's laws of motion, is that medyo matatagalan tayo dito, especially in understanding problems and making the free body diagram using the idea of vectors. Okay? So, I will switch my camera because I will be recording this one also using using another device. So, ayan. So, if you want, sorry, medyo awkward ang ano. Medyo awkward ang setup. So, ang camera ko ngayon nakikita nyo is parang presentation lang din. Okay? I will be uploading that one also. For this day, for tonight, kung pwede, i-disable nyo muna si Google Meet Grid. Kasi para mas makita nyo in full view si presentation. Kasi ako naka-enable ang Google Grid view ko is ang liit-liit na ng presentation. So if you have your Google Grid then enabled, kindly disable it and then i-pin yung ang presentation para si presentation lang ang nakikita in full glow na size. And then if you want, you could do the full screen also if you want. Okay? So, and then if you have questions, if you have clarifications, please don't hesitate to tell me, unmute your mic, and please don't hesitate also to chat in sa ating chat box. Especially if may corrections or especially if may mali sa algebra ko. I know na aminado ako, especially if the solution is kinda long, may mamali talaga ako niyan, especially with the signs. Okay? Sige, let's start with Newton's laws of motion. If you want, you could see the problems on your end using the Dagler. Okay? So for the first problem, by the way, first law of motion lang tayo tonight ha. And sana hindi tayo umabot ng 3 hours. Kahapon umabot kami ng 1 hour and 54 minutes. Pero nag-break kami in between. And we will also have a break in between. So for the first problem, first law of motion, draw the free body diagram of each figure shown. Consider the surface is frictionless. So you have here two situations, situation A and then situation B. So zoom ko lang muna si A. So we have to draw the free body diagram of this one. So ang question ngayon is, why do we need free body diagrams? We need free body diagrams because, di ba, sinabi ko sa lesson 1 and lesson 2 is that we are having our problems as idealized models. We assume that it is an idealized situation, idealization of what is what is real. So for this, FBD is actually an aid for us to understand first law of motion by doing modeling and by having it an idealized na model. For this, as you can see, meron kang dalawang box, box A at saka box B. We will not represent it as a box, but we will represent it as an idealized model, as a point particle. So kung point particle lang, it's really literally just a point. Okay? And then if bakit siya we represent that one? Because we will not take account muna ang size ng ating box. We will not account muna the shape of the box. We assume muna that all forces are being applied sa center of mass sa ating box. That's why point particle muna tayo. So let's have this one. So number 1, letter A. I hope maklaro nyo ang solution. Okay, so for free body diagram, you have here two boxes A and B. So you expect also na meron tayong dalawang free body diagram. We separate each of the boxes, but they are considered as a one system pa. Diba kasi si A connected lang ng B via a cable. So you have the FBD of A. Let's start with the FBD of A. Box A. Ayan. So first is, let's draw our X and Y axis. X and Y. So if may X and Y axis tayo, understandable na alam natin saan si positive X, positive Y. And then it is up to you kung saan ka mag-positive X and positive Y. Ako lang is that if to the right, it is always positive X. And going up, it is always positive Y. If gusto mo sa other side, opposite ka, to the left ka mag-positive, so dapat din, to the right mo, magiging negative X. Just take note of that one also. Okay? So, free body diagram of A, it is better for us to put our point particle at the center or at the origin of our X and Y axis. Ayan. And then, draw the necessary forces. Ang SOP ko dito is that, tignan mo muna, first, nasa surface ba, nakalagay ba sa isang platform? Next is, may cable ba? Next is, meron bang friction? Okay? Puro muna tayo contact forces first. So, if nasa table yan siya or nasa any surface, may it be nakapatong or parang nakahang siya, meron din siyang normal force. That normal force, by the way, this has been discussed sa sa na-post ko na video na resources. Okay? Yung introduction to free body diagrams. That normal force is it will provide support to our object. So, this will provide, itong table na to, meron siyang support na ibibigay sa ating box A. And then that support is always perpendicular to the surface. So, always 90 degrees siya with respect to the surface. So, that's why, always pataas dito, for this case, pataas ang ating normal force. Ang normal force ko, let's have that as Fn. Ayan. Pwedeng ganyan. If you want naman na normal force na nakapaganyan, okay lang ako. Okay, kasi ako, ang normal force ko during last year is ito. And I'm fine with that one. Pero kasi ang nilagay sa mga video resources and even sa ating book is itong naka-FN. Okay, so let's have that FN. Next is my cable. So if my cable, meron yan siyang tension force. And always remember that the tension force is always pointing away from the object. So away from the box. So connected siya sa right, so papunta siya sa right or pointing towards the right ang ating direction for our tension force. So let's have that one. Oops. Okay lang na hindi perfect si si mga vectors natin. Ito lang is, meron kasi akong grid. So, parang mas maklaro ang mamali. Ayan. So, let's have the tension, Ft. Yan. Next is, meron bang friction. Sinabi dito sa problem, consider the surface frictionless. So, there's no interaction between the bottom of our box at saka itong top ng ating table. So, there is no friction. Next is, non-contact forces wherein forces at a distance, isa dyan sila magnetic force, electromagnetic force, isa dyan si pull of gravity. Always remember that gravity is constantly pulling on our object. Hence, meron tayong force by gravity. And we call that for this case as our weight. In every mass, meron yan siyang kaakibat or equivalent na weight. Okay, so meron yan siyang weight ni box A, at saka weight ni box B. Ako, since para hindi ako malito, it's just a pull of gravity, I will have that as Fg na lang muna. Fg. And it's very particular, pull of gravity kay A, Fga. Okay? So, that's the free body diagram ngayon of my box A. Okay? And the next na free body diagram is the FBD of B. BD of B. Ayan. Same SOP. You have the X and Y plane. Ayan. And then, nasa center ang ating particle, si box B. And then the free body diagram. Si box B, wala siya sa surface, so nakahang lang siya, wala siyang normal force. Nakahang siya by a string na nakakabit papunta kay A. So, meron siyang tension force. Okay? So, ang tension force going away, so since nasa taas, so papunta pataas ang ating ang ating tension force. So, let's have that as Ft. Ayan. And then, meron siyang mass, meron siyang pull of gravity. The gravity is constantly pulling on it. So, you have Fg. Ayan. By the way, in getting the pull of gravity, by getting the weight, always remember that it's just Fg equal to the mass times the acceleration due to gravity g. That is 9.8 meters per second squared. No negative because we are just after the magnitude. Okay? So, if mapansin nyo, wala akong arrow on top na nilagay dito. Okay? Kasi we're just after the magnitude. Later ko na i-account ang direction if I will do the equations for the laws of motion. Okay? So, that's for my free body diagram for illustration A. Okay pa tayo? Kaya pa? This is kinda ano pa lang, preliminaries pa lang. And then I want you to familiarize yourself or to get the hang of making free body diagrams because paulit-ulit ito when you go to your professional subjects and also there are teachers kasi telling me from engineering na ito ha, hindi physics, na telling me na there are still students daw na natapos na ng physics, hindi pa rin alam paano mag free body diagram. Okay, so please make sure na bago ka pumunta sa isang subject na professional subjects na kailangan ng free body diagram, sana i-master mo muna kung paano or i-review mo muna paano gumawa ng free body diagram. Okay? So, that's for the free body diagram of A. So, FBDA, FBDB for letter A. Let's have letter B. So, for letter B, you have a system there composing of 3 boxes. A, B, at saka si C. Si A at saka si C, para makita nyo, madali lang i-gawin ang free body diagram. Pero si B, dyan kayo parang malito kayo kaunti dyan because it is on the ramp na paano natin siya i-consider ngayon na ang free body diagram ko is paano ko i-construct ang X and Y plane or X and Y axis. Nakapa-rotate ba or as is lang. Okay? Or anong itsura ba ng aking vectors for that one. Okay? Isa-isahin natin. Let's have FBD of A muna. FBD A. Yan. SOP, you have your X and Y. Ayan. And then, the point particle. So, si A, nasa surface. So, merong normal force. Always pataas for this case. Nasa 90 lang. Nasa 90. Nasa positive Y lang. Pataas ng ating floor. So, Fn, normal force kay A. Next is my tension force. Nasa right. Let's have that one. So, meron kang Ft. It's up to you kung paano mo i-denote ngayon ng Ft. Kasi as you can see, meron kang dalawang cables. Meron ka sa left ng B, meron ka sa right ng B. It's up to you if paano mo siya i-denote. Mag-Ft1 ka ba or Ftl? Or mag-Ft2 ka or mag-Ft right? Ako, let's have that as ano lang muna. As numbers. So, let's have that one as Ft1. Okay? Next is, still merong mass, pull of gravity. Always yan siya. So, you have FGA. Ayan. That's the free body diagram of A. By the way, let's assume that this is still following Newton's first law of motion pa for the free body diagram na exercises. Kasi if meron tong acceleration, iba ang free body diagram natin, dadagdagan natin na ito ng isang vector to denote the motion. Let's have FBD of B. FBD of B. Ayan. Paano ngayon ang free body diagram ni B? Always remember na nasa ramp siya. Okay, if nasa ramp nga yan, I suggest na i-rotate nyo na din kaagad ang X and Y plane nyo. Okay? So, rotate. Rotate ko lang ha. Or if you want twist, sige, twist. Lang. Make sure nyo naka-45. Ayan. So, this is our point particle. So, kayong bahala if ang pataas positive X or ang pababa positive X. Ako, this is positive X and this is still positive Y. Free body diagram, SOP, nasa surface, may normal force. The normal force always siya perpendicular to the surface or perpendicular this time to the ramp. So, nasa positive Y pa din. So, So, that's your normal force ni B. Let's have that as Fn B. Ayan. Next is my tension force nasa left at saka nasa right. So, let's start with yung nasa left. That's your Ft1 actually. You have Ft1. Bakit ko siya sinabing Ft1? Na same lagi ng Ft1 dyan sa kay A. Same sila na Ft1 because they are on the same, they are just connected by same string lang. Kung same string lang yan siya, same lang yan sila ng tension by magnitude. Ang tension, if let's say for example, ang tension ni Ft1 sa F using si FBD ni A, this one, is 10 newtons. Ito din dapat is 10 newtons. But take note of their directions. Iba-iba. Si Ft1, papunta kay positive x. While itong si Ft1 kay B is papunta kay negative x. Don't be confused about their direction. Okay? It will depend kung anong susundan mo na free body diagram. Okay? Next is the weight. Dito din nalilito or the pull of gravity. Dito din nalilito ang student. If nasa ramp is dinadiretso nila, sir, nasa negative y. Ganyan. That's actually wrong. Okay? The pull of gravity is always pointing downwards. Pababa yun na siya di always. So meaning to say, the pull of gravity for this one is wala sa negative y. But diretso siya pababa. So this is your FGC. Ayan. So that is now the free body diagram of your box B. But take note, the FGB is it's kind of difficult to use ngayon the first law of motion for this one. Especially if we will be making our equation, if we will have the summation of forces. Because we will have to isolate, just like a projectile motion, we have to isolate yung mga x components and then the y components. So we need to decompose this pull of gravity to its components. Dapat ma-express natin yan siya into x and y components. So meaning to say, meron itong y component, fg dy, and then meron itong x component, fg dx. Ayan. Paano ngayon niya makuha yung x and y components na yan? You need to make use of your SOHCAHTOA with your trigo. Okay, so kailangan mo ng angle. Ang angle na gagamitin natin is actually ito na angle dito. Yang theta na yan. And mind you, that theta is just equal to kung ano yung angle ng ating ramp. The angle of the ramp is 36.9. So that angle theta should be 36.9 also. Paano makuha? Kasi I know some people are confused. Some of you here na alam nyo na ito kung paano ko nakuha itong si 36.9. Because I have familiar faces here. I have derived this already during your senior high school years, but for the benefit of everyone. So let's go back to the ramp. It is just taking advantage of our right triangle. Yan. And then, this is, let's say for example, the x and y. Yan. 45. Tapos, ito si, oops. Let's just move that one. Yan. Okay? Ang hinahanap natin na angle is this one. Yan siya. Let that be alpha muna. Okay? So, take note of this one, of this triangle. This is just a right triangle. And also, this is also a right triangle. Ito dito. Okay? So, let's have different variables. Let's say, for example, this is theta and this is beta. And for all we know, at this point, this is just a right triangle. Right triangle. This is just 90 degrees. Kasi nga, this is belonging to a right triangle. Nandiyan si perpendicular. So, meaning to say, we could have 90 degrees that is just equal to alpha plus beta. Let's leave it there. Okay? And then let's have this one. Ito. This is also a right triangle. So, meaning to say, 180 just equal to theta plus beta plus 90 degrees. So, we could have 90 that is equal to theta plus beta. Or we could express this beta in terms of theta and 90. So, we could have 90 minus theta. Okay? We substitute this one papunta sa equation na to. So, what will happen is that you could have 90 equal to alpha plus beta, that is 90 minus theta. So, you could have 90 equal to alpha plus 90 minus theta. This will cancel out. So, you could have alpha, not alpha, let's have the theta na. So, you could have theta that is equal now to alpha. So, meaning to say, if alpha is 30 degrees, this angle here should be 30 degrees. If this is 45, this should be 45. 39, so this should also be 39. Okay? So, meaning to say, kung anong angle ng ating ramp, that is 36.9, ito din angle natin dito. Okay? And then ako, sa free body pa lang, I want to express na my FGBY and my FGBX. So with respect to this theta here, the FGBX is the opposite side, right? So katuwa, so I only have C sign as opposite over hypotenuse. So I could have FGBX that is equal to FGB sine theta. And then CY, with respect to theta, this is the adjacent side. So adjacent hypotenuse. So FGBY, this is just equal to FGB cosine theta. Okay, so don't forget your SOHCAHTOA. This is just from SOHCAHTOA. Okay, that's from your trigo. I hope na hindi nyo pa nakakalimutan si trigo nyo. Okay, so that is the free body diagram of B. So if may ramp nga, always remember na i-rotate na lang natin, i-twist na lang natin ating x and y axis by that angle theta. And kung ano yung value ng ramp, yun din ang value. Yung value ng angle of inclination ng ramp, yun din dapat ang angle ng ating weight with respect to the negative y axis. Okay? So, I hope you don't forget about that one. And then, by the way, I'll be sending a copy of this Blackboard also. Itong solutions na ginawa ko. PDF copy sa Day Garden. I will upload this one also. Okay, so let's have the FBD of C. The free body diagram of C. Ayan. So, point for X and Y. The FBD of C is very easy. SOP, walang normal force kasi wala sa surface, but you have the tension force pointing up. So, this is FT2. Sorry, hindi pa pala ako tapos dito for B, sorry. Nakalimutan ko sa tension force sa right ng ating vector, ng ating particle, ng ating box B. So, this is FT2. I will have that as FT2. Sorry. Ayan. Hindi pa pala tapos. So, I have FT2. And then I have the weight of Maxi. So FG, ayan. So that's the FBD of particles. Okay? So that's for problem number 1. I will provide you with a copy of this one so that we could easily move on with the next problem. Kasi baka may nagkokopya, tapos medyo mabilis ako magsalita and mabilis ako magsulat. Okay? So this is for number 1. Let's have number 2. Number 2 pa din, para pa rin itong exercise. There's wala pa ito masyadong pagbuo ng mga equations. But understanding first law of motion pa ito, mostly. So number 2, the systems shown in the figure are in equilibrium. So it should follow first law of motion. And by the way, first law of motion, sinasabi dyan if acceleration is equal to 0. Meaning to say, if it is at rest, it should be at rest perpetually. If it is moving in motion, it should be moving at a constant speed, not changing, so that acceleration should be equal to 0. So the systems shown in the figure are in equilibrium. If the spring scales are calibrated in newtons, so you have here the spring scales, yan sila sa center, okay? What do they read? Ignore the masses of the pulleys and springs and assume the pulleys and the incline in part D are frictionless. So you have here 4 situations, A, B, C, and D. Okay, so let's start with A. Si A is may dalawang nakahang sa spring scale. Actually, ang support na binibigay ng right na spring scale is para mag-stand still or para at not at rest, parang makasupport si 5 kilograms na right papunta kay spring scale so that ganito ang setup. Ang question is, ano daw reading na ating spring scale? Okay? So let's have the free body diagram. Actually, we are only after the one free body diagram for this one. Kasi as you can see, if this is massless, itong si spring scale, it is as if na si 5 kilograms na ball sa left is just connected to the 5 kilograms na ball sa right na via a single string or a single cable. So meaning to say, uniform ang tension all throughout. Kung anong tension na makukuha natin dito sa one side of the 5 of the spring scale is yun din ang tension sa other side ng ating spring scale. Okay? So let's just consider itong nasa left. FBD of 5 kilograms. I will just have the 5 kilograms lang para in general. Kasi the same sila ng FBD ni 5 kilograms sa left at saka ni right. So we now have X and Y. Ayan. So free body diagram. So wala sa surface but meron tayong tension force. So you have FT. And then you have the weight of our ball. Subject that as FG. So solving for FG. Solve muna natin sa FG. Where FG is just equal to mass times the pull of gravity. So the acceleration, the magnitude. So this is just 5 kilograms times 9.8 meters per second squared. So this is equal to 49 newtons. Ayan. By the way, 1 newton is equivalent to 1 kilogram times meters per second squared. So if meron kang nakitang kilogram meters per second squared, it is in newton. Especially if forces. Okay? So you have 49 newtons for this one. So since this is just following first law of motion, if mag-solve ako, ganito ang ginagawa ko is that sinusulat ko muna is anong law of motion ang na-obey. So parang alam ko, guided ako all throughout. So this is first law. So if first law, summation of all forces should be equal to 0. So magkasabayan siya, summation of forces sa x equal to 0 and summation of forces sa y equal to 0. Kayong bahala anong unahin nyo, mag-x ka or mag-y ka. It will just be, it will just give you several equations. And then, you take note also kung ano naman, anong better na gawin sa free body diagram ko. If mag-x ako or mag-y. And by inspection, look at your free body diagram of our 5 kilograms. It is wala kang wala kang x component. It is all in the it is all y component. So meaning to say, why not take advantage of the summation of forces so y? Okay? So using that one, summation of forces so y equal to 0. Now you have ft and then you have fg. Ft is going up, so it should be positive. So you have positive ft. And then you have fg, that is going down. So it should be negative. So minus fg equal to 0. So ft is just equal to fg. So ft pala, na-solve na natin si fg, that is just 49 newton. So ft pala, this is just equal to 49 newton. And that ft is actually the reading of our spring scale. Okay, it is calibrated now in newtons. Um, I will show you a picture of the spring scale during our laboratory. Okay, kasi si spring scale, this is just parang the same lang siya with the weighing scale. Pero iba lang ang calibration and medyo sensitive ang spring na ginagamit dito. Okay? So our answer for this one is kung ano yung reading ng tension, ano yung tension force, yun din ang reading ng spring scale. So you have 49 newtons na reading sa ating spring scale. Okay? So let's have this is letter A, by the way. Let's have letter B. Ayan. For letter B. Letter B, it is as if parang the same lang sila ni situation A. 'Di ba? So if mag-draw ka pa din ng FBD dyan, sige, SOP natin. Kasi pinapa-SOP ko kayo na gawin dapat ang FBD always. So FBD of the 5 kilograms. If sanay ka na mag-FBD, there's no need to write your positive X, positive Y. Yung iba nga, ganito nang sinusulat diretso. So you have FT, then you have your FG. Ganyan. Okay, where FG pa din is still equal to 49. So for this one, first law pa din ito. And then puro tayo Y component. So summation of forces sa Y equal to 0. You have FT minus FG equal to 0. So FT is just equal to 49 newtons or equal to F. So halos the same lang talaga with situation A. Okay? So that's for our letter B. Let's have letter C. Ayan, letter C. The letter C, this is a good example. This is actually an Atwood's machine. Si Atwood's machine, makikita natin yan siya unconsciously sa ating elevator. If meron tayong unbalanced na mga masses dito, one will go up, one will go down. Okay? And then if makita mo sa likod ng elevator, if nakakita na kayo ng elevator na yung transparent ang likod or nakikita ang loob mismo, ano yung mechanism niya is merong several weights. Ito yun siya. Ganito yun siya, si elevator natin. So, ang tanong dito is, you have two 5 kilograms na nakahang via pulley and the pulley is daw massless. Ano daw ang reading ng ating spring scale? Okay? So, let's have the free body diagram of the pulley. BD of pulley. So, you have the pulley. Ayan. And then, dalawang string ang nakakabit sa kanya. Okay? So, not dalawang string. Dalawang path. Okay? And that string is coming from the left papunta sa right na spring, na mass, of 5 kilogram na mass. And they are just the same string. Okay? But I will write it as FT lang muna silang dalawa. So, we could have here FT. Ayan. And then you have here FT. Let's have that as FT1 and then FT2. Kasi there are instances na iba-iba ang kanilang mga values, especially if they are accelerating. So, para mas masanay tayo, mag-FT1 lang ako and then FT2. Okay, and then, meron ka pang string na nakakabit sa ating spring scale. Pataas. Let's have that as Fs. Kung ano yung Fs, yun ang reading ng ating spring scale. Next is the FBD of our 5 kilogram. Kilogram. Let's have itong sa left and then sa right. So you have the point particle. You have FT1. You have FT. Let's have that as A. And then FT2. And then FGB. For all we know, FGA and FGB, they are just the same. Ayan. So meaning to say, FG, that is just equal to 49 newtons. That's 5 kilograms times 9.8 ha. This is just equal also to FGA na equal din kay FGB. Okay? So let's get FT1. So this is just again first law of motion. So first law. So summation of forces equal to 0. And then you have several free body diagrams na here. Anong gagamitin yung first? I will use muna the 5 kilograms sa left. Ayan. So summation of forces sa Y equal to 0. So I have FT1 minus FGA equal to 0. So FT1 is just equal to FGA na equal lang kay 49 newtons. Okay? And then 5 kilograms sa right. So summation of forces sa Y equal to 0. You have here FT2 minus FGA equal to 0. Sorry, this should be FGB equal to 0. So FT2, which is equal to FGB, which is equal to 49 newtons pa din. Ayan. Next is, let's now use the free body diagram of the pulley. Kasi nandun ang reading ng ating spring scale. So using the FBD of the pulley. So you have, obviously, sa pulley, wala tayong X component. Puro tayo sa Y component. So summation of forces sa Y equal to 0. So you have Fs going up and then dalawang tension forces going down. So you have Fs minus Ft1 minus Ft2 equal to 0. So Fs just equal to Ft1 plus Ft2. So that is just 49 newtons plus 49 newtons. So Fs natin, reading sa ating spring scale, is 98 newtons. That's our answer for letter C, for this Atwood's machine. Okay? So if nakita nyo, dalawang spring scale, isang spring scale, tapos may dalawang nakahang na, it will give us 98 newtons via pulley ito. Pero yung kanina kay A, dalawang mass pa din, pero directly connected kasi. So ang reading pa rin dito is still equal lang kay 49 newtons. Okay? Let's have letter C. Letter C, letter D. Si letter D is kinda tricky. Kasi baka sabihin nyo kaagad na ang reading dyan is still 49 newtons. Well, it is not 49 newtons anymore because nasa ramp na siya. There's an additional support. Okay? So, if meron yung support dyan, or additional support, is that always remember baka na mag-lessen ngayon ang ating answer. Okay? Kasi, there are people na, let's say for example, have normal force. Dati sinasabi nyo normal force is just equal to the weight diretso. Which is not, that's wrong. It is not always equal to the weight diretso. You have to analyze the problem first. Okay? For this one, it's the same. So, para mas maintindihan natin siya, is you still draw the free body diagram for this. So, D. And then, nasa ramp, let's rotate the free body diagram. We have FBD of 5 kilograms. Yan. So, rotate lang natin. Yan. So, you have, obviously, meron kang normal force. And that normal force is perpendicular to the surface. So, papunta siya dito. So, this is your normal force, Fn. And then, obviously, meron itong tension force. So, you have there Ft. Kung ano si Ft, yun ang reading ng ating spring scale. And then, you have the weight. Yan. Fg. Now, and the angle between the negative y and Fg, this is equal to 30 degrees. Okay? So, nakita natin na sa Fg is going down. Wala siya naka-x and y components. So, decompose natin into components. So, you have this one. So, this is our Fg, y. Ayan. And then you have Fgx. And then, with respect to 30, Fgx is still the opposite side. So, Fgx is just equal to Fg sine 30. And then, Fgy, adjacent side, so cosine, Fg cosine 30. By the way, it is not always the case na if x, diretso ka mag-sine. Okay? You always look at muna kung anong side si Fgx with respect to that angle. So, we could now solve. By the way, still Fg is equal to 49 newtons. Hindi yan magbabago. That is 5 kilograms times 9.8. So, using this free body diagram, and using na first law pa din ito. Ayan. So, summation of forces equal to 0. You decide, summation of forces sa x or summation of forces sa y. Look at summation of forces sa y first. If mag-summation of forces ka sa y, ang makukuha mo dyan is the normal force. Kasi sa normal force lang ang unknown. Okay? Kasi makukuha mo ito sa FGY if alam natin sa FG. So, meaning to say, hindi mo makukuha ang reading ngayon ng spring scale. But ang makukuha mo is the normal force. So, dun ka na diretso, summation of forces sa x. Why? Kasi, nandyan si tension force. So, nasa x is tension force, and then you already know what FGX is. You could solve for the tension force. So, summation of forces sa x equal to 0. So, this is positive Ft minus Fgx equal to 0. So, Ft is just equal to Fgx. This is equal to Fg sine 30. So, this is 49 newtons sine 30. So, Ft is, I hope we have the same answer. If you have your calculators there. So that's 49 sine 30. So you have 24.5 newtons. That is now your answer. That is the reading now of your spring scale. And that is 24.5 newtons, which is lesser than the weight of our object. Kasi nga, meron na tayong support. If meron pa yung isang cable, it would become lesser actually. And if meron yan siyang humihila pababa, then it could become greater than 24.5 newtons pa din. It is circumstantial, that's why some problems here in the physics for engineers na sa university physics na book is will entail you to have different kinds of analysis. So I suggest is you and solve as many problems as you can. Okay, especially na we are in the online na situation, it's kinda difficult to ano to, to give you or to monitor you in your answering of your sheet work. So I suggest you and solve. And then also you you listen, not listen, you watch the videos that I have suggested. If ayaw nyo magbasa, at least man lang makita nyo siya doon. Okay? And please naman, if may time, basa-basa din tayo. Kasi nakita ko din ito sa sa nakikita ko kasi sa view counts ng mga videos na especially yung ako ang gumagawa is ko konti lang din talaga ang nanonood. May it be easy lang na subject or not is there are instances na si student is mas prefer niya dumiretso kay problems diretso without knowing bakit siya ganoon. So, go through with the lecture videos, yung mga suggested videos ko, go through with that one para mas maintindihan mo ang mga problem. Okay? So, that's for number 2. Let's have number 3. By the way, let's have number 3 and then let's have a 10-minute break. Okay? Number 3, this is paulit-ulit ito na problem actually. Itong problem na to, if the topic is first law of motion, is paulit-ulit itong ganito na problem. Okay? So a traffic light weighing 122 newtons hangs from a cable tied to two other cables fastened to a support as shown. The upper cables makes angle of 37 degrees and 53 degrees with the horizontal. These upper cables are not as strong as the vertical cable and will break if the tension in them exceeds 100 newtons. Does the traffic light remain hanging in this situation or will one of the cables break? So you have this situation. You have several tensions, T1, T2, and T3. And I will be using this notation muna for this problem. So ang question is T1, T2, can T1 and T2 withstand this light that is weighing 122 newtons? If not, meron bang mag-break? Ano yung mag-break? Si T1 ba or si T2? Because they could just withstand lesser 100 newtons na force. If mag-exceed siya ng 100 newtons, then T1 might break or T2 might break. Okay? So let's have the free body diagram for this one. For number 3. Ayan. So, dalawang FBD ang gagawin natin dito. Let's have the FBD of the nut. Ano yung nut? Ayan, sir. For connection point. Or connecting point, rather. Ang connecting point ng ating tatlong strings, itong sa center mismo. Igawan ko yan ng free body diagram dyan. So, X and Y. Ayan. You have T1, T2, and T3. I will use the notation T1, T2, and T3 para hindi lang malito sa ating illustration. Let's have this as T3. Sorry. This is not T3. This is T2. And then we have T1. And then lastly, T3 going down. As you can see, T1, T2, and T1 and T2 is at a certain angle theta. And this is 53. And this is 37. Okay? So, if 53 and 37 dyan, ito din dito, by trigo, this is 53, congruency of your angles, this is just 53 degrees also. Sorry, not Celsius, degrees lang. Sorry. Nasa thermo na kasi kami sa senior high. And this is 37 degrees. Ayan. And decompose ito components. You have T2x, then you have T2y. And then you have T1x, T1y. Ayan. Next is, let's express our T1, our x's and y's. So, where muna tayo dito? Where? Ayan. With respect to 53, to 37 rather, si T1x is adjacent side ngayon. So, mag-cosine tayo. So, this is T1x equal to T1 cosine 37. And with respect to say 37, si T1y is the opposite side. So, T1y is equal to T1 sine 37. And then you have your T2x and T2y. Si x pa din is adjacent and si y is opposite. So, T2x, this is T2 cosine 53. And then T2y is T2 sine 53. Ayan. And then let's have the free body diagram of the street light mismo. FBD of light. Ayan. So, free body diagram of the light. You have T3. And then you have the weight of the light. So, FG. Ayan. So, where FG, meron ng binigay na weight sa atin, weighing the 122 Newton. Ayan. A traffic light weighing 122 Newton. Ayan. So, we can now solve for our T1 and T2. So, let's solve for T3 first by using the free body diagram of the light. And take note, this is still under first law of motion. So, summation of forces equal to 0. So, using the summation, the FBD of light, let's take advantage of the y component. So, summation of forces of y is equal to 0. So, this is just T3 minus Fg equal to 0. So, T3 is just equal to Fg. So, meaning, the tension T3 pala is just equal to 122 Newton. So, it is telling you na, let's say for example, tinali mo yung bag mo na 5 kilos. So, 5 kilos times 9.8, tapos ihang mo siya, yung 5 kilos times 9.8, yun na siyang tension ng cable diretsyo. Okay? So, you have there T3 already. Next is, obviously, wala na tayong summation of forces sa X sky light, sa FBD ng light. Let's go to the free body diagram of the nut. So, FBD of the nut. Ayan. So, Kayong bahala if mag-summation of forces ka sa X or mag-summation of forces ka sa Y muna. It's really up to you for that one. Kasi either way, this will give you an equation. Wala ka munang ma-solve in one equation lang. So, summation of forces, let's start with X equal to 0. So, sa X, you have T1X and then T2X lang. So, this is negative T1X plus T2X equal to 0. Where T1X, this is T1 cos 37. So, this is negative T1 cos 37 plus T2X. Ang T2 natin, this is T2 cos 53 equal to 0. Now, see, dalawang unknown, T1 and T2. So, dalawang unknown, hindi mo yan siya masosolve in one equation. And hindi mo masasubstitute yan si T3 dyan, papunta sa equation na yan. Kasi walang T3. So, you leave that hanging muna. Let that be equation number 1. Let's take advantage of the Y component equal to 0. Summation of forces of Y equal to 0. You have T1Y and T2Y going up. And then T3 going down. So you have T1Y plus T2Y minus T3 equal to 0. So you have T1 sine 37 plus T2 sine 53 minus T3 equal to 0. Yan. So, meron kang T1, meron kang T2 and T3. You already know T3 and that is just 122 newtons. But you don't have T1 and T2. Diba? And then, may T1 and T2 sa equation number 1. So, for this case, kayong bahala kung anong gusto nyo unang ma-solve. If gusto nyo unang ma-solve si T1 or gusto nyo unang ma-solve si T2 muna. Ako gusto ko unang ma-solve si T1. That's why I want to express this equation sa Y muna as T2. Kunin ko muna si T2. So, this is just algebra. T2 is just equal to T3 minus T1 sine 37 all over sine 53. Algebra ito ha. Just review your algebra. So, this is now your equation number 2. So, you can now substitute that equation number 2 papunta ngayon kay equation number 1. So, substitute 2 in 1. So, lahat ng may T2 dito sa equation number 1 is substitute, sorry, tama ba? Yeah. Lahat ng may T2 dito is isubstitutean mo ng T3 minus T1 sine 37 over sine 53. So, this will become negative T1 cos 37 plus T2. So, T3 minus T1 sine 37 over sine 53 cos 53 equal to 0. Ayan. So, kayong bahala kung sorry, nakalimutan ko si T. Tama pala. Equal to 6, tama. Kayong bahala kung anong gawin nyo next for this one. Okay, it's really up to you how will you go about it. If gusto nyo i-express si cos 53 over sin 53, okay lang din. But ako, I find this na parang a good practice din. Why not? I will just multiply both sides by sin 53. Ayan. Baka malito kayo, just follow with this one muna. If meron kayong other way na or other solution, I welcome that solution. Okay? So, I'll just multiply both sides by sin 53. So, this is negative T1 cos 37 sin 53 plus, mag-cancel out na si sin 53. This will become T3 minus T1 sin 37 times cos 53 equal to 0. I want to distribute cos 53 sa loob ng T3 at saka negative T sin 37. So, T1 cos 37 sin 53 plus T3 cos 53 minus T1 sin 37 cos 53 equal to 0. Ayan. So, that's my equation. And then, I want to isolate T1 kasi si T1 ang gusto kong kunin. Kasi si T1 na lang din ang unknown dyan. Kasi alam ko na si T3. So, what will happen is that I have here T1 now. I will isolate T1. I will regroup T1. T1, that is just negative cos 37 sin 53 plus, negative sin 37 cos 53. Ito siya ha. This one and this one. Equal to negative T3 cos 53. So T1 just equal to negative T3 cos 53 all over negative cos 37 sin 53 minus sin 37 cos 53. So this is equal to T3, that is 122 newtons cos 53 all over negative cos 37 sin 53 minus sin 37 times cos 53. So T1 is equal to I hope you are doing the calculations also. Answer for this one, this is equal to 73.4 newtons. Now that is the value of T1. So will it break si T1? Obviously, it will not break because it will not exceed 100 newtons. Okay? And then also, ito din. Baka may makakuha sa inyo ng negative or may if you are solving Newton's laws of motion, if makakuha kayo ng mga negative na values, and then you have accounted for the direction, please recheck your solution. Kasi, what we are expecting here na mga values, especially T1, T2, T3, F1, F2, is that mga magnitudes lang kasi ito sila. So, we expect na positive na mga values ang ating makukuha lahat. Okay? Please take note of that one. So, T1 is 73.4 newtons. So, paano kunin si T2? So, you just have to substitute T1 and T3 papunta ka equation number 2. This equation right here. Okay? So, substitute T1 and T3 in equation 2. So, I will just copy-paste lang ha. Okay. Ayan. So, this is just equal to T3, 122 newtons, minus T1, 73.4, sin 37, all over sin 53. So, T2 is now equal to 97.4 newtons. So, si T2 almost siya mag-break kasi close to 100 newtons na siya. Okay, so that's the values of your T1 and T2. So that's for problem number 3. I hope you're still there. Hi guys, how are you? Hello? Nandyan pa ba? Yung iba dito kumakain na. Siguro. Guys, there's no way for me to tell if nandyan pa kayo.
Yes, sir.
Ay, nandyan pa. Very good. Okay, let's have a 10-minute break. Break muna tayo. Okay lang? So, it's 6:49. So, round off na tayo 6:50. Let's go back 7 p.m. Okay? Para maka-refresh lang man kayo and then maka-replenish ng snack or kain mo na konti. Okay? And then we will end by, actually this is up to 7:30. We will end by 7:30 later. Okay? Depende kung madali tayo magtapos sa next two problems. Sige, sige. Break muna tayo. I will turn off the camera and then I will mute and then let's have a break. 10 minutes break lang. Okay, hi. Hi again. Let's proceed. By the way, I'm viewing the recording na ginawa ko. Medyo laggy, so medyo fail. So I will just stick with the recording with, with the Google Meet na recording. Okay. Let's have example number 4. Number 4. Yeah. So this is kind of familiar for some people here. A a 1,130 kilogram is held in place by a light cable, by a light cable on a very smooth frictionless ramp. The cable makes an angle of 31 degrees above the surface of the ramp, and the ramp itself rises at 25 degrees above the horizontal. Draw the free body diagram for the car. Find the tension in the cable and how hard does the surface of the ramp push on the car. So FBD, tension, and then the support given by the ramp papunta kay car. So this is our illustration. Ayan. So let's start with, by the way, I will not record na with my ano. So let's go back to regular programming of my camera. So let's have letter A. We have to draw the free body diagram. Lucky for us, we only have one object for this system, and that is the car. So FBD of car. Okay, so since it is on a ramp, so rotate natin si X and Y. Yan. And then point particle, we will have this as positive X to the right, going up and then going up to positive Y. So FBD SOP natin, we have the ramp, so we have the normal force, the support. Oops. Ayan. So let's have FN. We have the tension force, the cable that is at 31 degrees. So that as FP. We have the weight, is diretso down. So you have FG. Ayan. So as you can see, wala tayo sa X and Y, si FT at saka si FG. So decompose tayo. So this is 31 degrees and this is 25 degrees. So we have FTX. And then we have FTY. We have FGY. We have FGX. Okay, so let's express our FT and FTX and FTY and FGX and FGY. So with respect to 31 degrees, the FTX is nasa adjacent side. So where FTX is just equal to FT sa cosine 31 and FTY opposite side. So this is FT sine 31. And then FGX and FGY. FGX is opposite side. So this is FG sine 25 and FGY adjacent side. So this is FG cosine 25. And then we could solve for FG because we are given the mass of the car. So FG just equal to the mass of the car, 11,030 kilograms or 1,130 kilograms times 9.8 meters per second squared. So FG is 11,074 Newton. And yeah, let's have this one na. Still, it is following first law of motion. So first law, so summation of forces equal to 0. So let's have letter B because that's basically letter A. So for letter B, we are asked about the tension force. Sige. So paano natin makuha ang tension? Mag-X muna ako or mag-Y muna ako? So you do inspection. Let's start with the X. So I have here FTX and then FGX. I can solve for FGX because I already know FG and then I have the angle. So I could solve for FTX. Summation of forces sa Y. I have here FTY and then I have FN and then FGY. I don't know Fn and then FTY. So two unknowns ka kaagad sa summation of forces sa Y. So just leave it hanging muna si summation of forces sa Y. Kasi wala tayong makukuha dyan. So let's have summation of forces sa X. Summation of forces sa X equal to 0. So you have, by the way, papunta dito is positive X, positive Y pataas. Okay, so you have FTX minus FGX equal to 0. So substitute ko lang sila FTX and FGX. So this is FT cos 31 minus FG sin 25 equal to 0. So FT just equal to FG sin 25 all over cosine 31. So this is equal to FG 11,074 sin 25 over cos 31. So FT is this is 5,459.93 newtons. Or I'll go to the significant figures of my given, and that is 1,130. This is 3 sig figs. I have 31.03 and 25.03 sig figs. So gusto ko, I will be expressing my answer into 3 significant figures. So FT, this is 5, 4, so 5, 9, so 9, ang kasunod ni 5, so it's closer to 6. So 5, 4, 60 newtons. And that is now our answer. For letter B. For letter C, so I have to solve for the support given by the ramp. So basically, that's the normal force. So, wala ka ng kawala, summation of forces sa Y na yan siya, diretso. So, summation of forces sa Y equal to 0. So, you have FTY and FN positive and then FGY negative. So, you have FTY plus FN minus FG equal to, FGY rather, equal to 0. So, FTY ko, this is FT sin 31 plus Fn minus Fg cos 25 equal to 0. So Fn, so this is Fg cos 25 minus Ft sin 31. So substituting Fg cos 25 minus substituting Ft, kayo bahala if you want to have the 5459 or 5460. Pero rule of thumb is yung hindi pa naka-round off. Mamaya na tayo mag-round off. So this is 5459.93. Move ko muna ha. 93 newtons sin 31. So Fn, This is equal to 7,224.38 newtons, or the normal force is 3 sig fig 7,220 newtons. By the way, si 24 closer siya kay 20 compared kay 30. Hence, 20. So that is now our answer for letter C. So the support that is given by the ramp papunta kay car is equal to 720 newtons. Okay? Sige. We will now have the last problem sa wakas. So sample problem number 5. By the way, again, I will have the continuation of this one on Saturday. Okay? So sa Saturday na si second law of motion. Yeah. Have this. Number 5. Number 5 is easy ito, pero it uses the idea of friction kasi. So friction, you have two kinds of friction. You have static and kinetic friction. So once that your object is in motion already, it is experiencing kinetic friction. But if it is not in motion, it is just at rest, impending pa ang motion, or about to start pa ang motion, ang friction na nag-act sa kanya is static friction. Okay? So for this sample, consider the system shown. Block A weighs 45 newtons and block B weighs 25 newtons. Once block B is set into downward motion, so may motion na, it descends at a constant speed. Calculate the coefficient of kinetic friction between the block A and the tabletop. So that's why it is already set in motion. That's why we are to solve for the kinetic friction. In solving for, not kinetic friction, coefficient of kinetic friction. So, in solving for friction, ilagay ko lang F muna ha. Friction is just equal to mu times a normal force. Ganyan kasi ako para fun. Or for us, this is force F equal to mu times the normal force. Ang magnitude lang ito ha. Okay. So if static friction yan siya, so you have coefficient of static friction times the normal force. But if it is kinetic friction, so kinetic friction force is just equal to the coefficient of kinetic friction times the normal force. So I will just write here X. Kayong bahala, kinetic ba yan siya or static friction? Fs yan, mu S. Fk yan siya, mu K. Okay? So there's a video for that one sa tile na nakalagay sa ating Baker. So we are to solve for mu K. Okay. Let's solve. Trace ko lang. So one system, two boxes. So let's have the free body diagram of A. Yan. So X and Y. So you have the normal force. You have the weight, FGA. You have the tension force, right? You have that FT. Now, ang motion natin, it is going to the right. Kasi set in downward motion man si box B. So, pababa. So, mahila niya si A. So, to the right si A. So, for the direction of the friction force, it is always opposite to the direction of the motion. So, if the motion is to the right, so ang direction for our friction force is to the left. So, papunta sa left ang ating friction force. So, you have there F. Lagay ko lang K. FFK. Ayan. Okay? So, FBD, DB. So, I have this one, X and Y, if you want. Pero ako, isahin ko na ito kasi one Sa Y lang man ito. So I have the FT going up, and then the weight of B, FGB. Yan. Now, sir, it is in motion. Paano natin nasabi yan siya na first law? First law yan siya because context clues ito ha. Once block B is set into downward motion, it descends at a constant speed. Constant speed, the speed is not changing, acceleration should be equal to zero. So it should be obeying first law of motion. Okay? So first law. Oops. So first law. Motion of forces equal to zero. So let's now have, ano ba? Kayong, I will now have B muna. I will use the FBD of B because mas madali siyang isolve si tension force dyan. May makuha ako kaagad. So, summation of forces sa Y equal to 0. So, I have FT minus FGB equal to 0. So, FT is equal to FGB. So, we are given already the weight of box B and that is 25 newtons. So, FT, this is 25 newtons. Okay? Leave it there. Let's now use FBDA. Ayan. Summation of forces sa X or summation of forces sa Y, kayong bahala. Ako muna is, kunin ko muna si X. So, summation of forces sa X equal to 0. So, I have there FT and then FFK. So, FT minus friction force equal to 0. Wherein, in solving for friction force, i-wear ko ito ha, yung kanina, solving for the friction force Fk, this is just mu k times the normal force. So, I now have Ft minus mu k times the normal force equal to 0. So, so not Ft. So, I can now solve for mu k kasi si mu k ang hinahanap, di ba? So, mu k now is just equal to Ft over Fn. Ayan. That is algebra. So, para makuha ko si mu k, kailangan ko si tension force. Na-solve ko na yan siya kanina. And that's 25 newtons. Pero, wala akong normal force. So, si normal force, by inspection, nasa summation of forces sa y. So, summation of forces sa y. Using pa rin FBD of A. So, summation of forces sa y equal to 0. I have their normal force going up. And then the weight, the pull of gravity going down. So, this is normal force minus FGA equal to 0. So, Fn is just equal to FGA. So, the normal force is just equal to the weight of block A, that is 45 newtons. Yan. So, you could now solve for mu k. So, mu k now is just equal to Ft over Fn, and that is Ft 25 newtons over 45 newtons. So, mu k equal to 0.55556 or 3 sig figs. This is 0.556. That is now our answer. The coefficient of friction, they're always unitless. Okay, and sometimes it is lesser than 1 and close to 1, and sometimes mag-equal siya kay 1. Okay, so that's the solution for sample problem number 5. Okay, so any questions so far? Any questions? Na nag-start ta og 15 ata ganiya, 16, 11 na lang ta. I understand nga ano 'to, medyo mahirap talaga ito. And baka nawala ng internet and may nagsabi din sa'kin na rotational ang brownout sa kanila. So, that's for first law of motion, problems 1 to 5. We will have this again in this coming Saturday. Okay? So please reserve your energy on Saturday. We will have this discussion again. Sample problems. Kasi I want this to be in real time, especially in dealing with Newton's laws of motion. This time lang din ito. Kasi I really want you to perfect in understanding Newton's laws of motion and to perfect your free body diagrams. I just want to, to explain it further. Kasi mas ma-explain ko siya if may nakikinig diretso kaagad na student. Okay? Do you have questions, guys?
None, sir.
None. Sige. So, I will end the recording. By the way, if mag-record ako, may na-email ba sa inyo na na email regarding the recording? Wala. May
Wala po,
ma-receive kayo
sir.
na email? Wala? Oh, so dapat pala talaga i-upload ko siya. Kasi sa akin nasi-save. Kasi akala ko diretso siya kaagad sa mga participants. Hindi pala. Sige. I'll just upload this one. Siguro makita nyo siya by tomorrow. Kasi I have to download and then re-upload it again sa YouTube. Okay, so I will stop.